Hey there YouTube, Nicholas from Game Dev Maniacs here. Welcome to this sixth episode in the beginner series where we learn how to make a simple 2D action game from scratch called Showdown. So in the last video, we learned about user input and created a title screen that transitioned into the gameplay. We reused a combination of concepts that we had learned previously to pretty much finalize the end-to-end experience. And the current result is a game that anyone can play and beat. But as we mentioned last time, it's just not very fun to play. So without drilling too much into new programming concepts, because I do want to keep this series fairly simple, there are still a few things that we could do to make the game a bit more exciting. So first, it's really hard to test the player's reflexes if the game's timer is set on a fixed scenario. It'd be much better to surprise the player and have them stay on their guard before having to pull the trigger. And we can use some randomness to create this element of surprise. Second, finding the right difficulty of the game is always something that's challenging. Currently, we give the player 1 second to shoot, which can seem like a lot for some people or just not enough for others. And a more fun and inclusive way would be to have players test their skills by starting with an easy opponent and then having additional levels where they move towards increasingly more difficult opponents to beat. In other words, they will have less and less time to shoot the opponent with harder levels. And lastly, I think we should provide some sort of new final state to represent the actual end of the game, some sort of reward as an achievement for completing the game. We're going to tackle the first two elements together, and then we will have the last element be one of the challenge for this session. So in order to add some randomness, Pico8 actually provides a very handy function called RND. RND will get a random decimal number between 0 and n. The upper range needs to be provided as an argument when calling the instruction. So if you look at the code below, we create a variable called lottery number, and we assign a random number between 0 and 69.9999. As we print it, we can see that the result is 35.4735, but if we were to use the instruction RND 70 again, we would get a totally different number. Now, a lot of the times you may actually want to get rid of the decimal part of a number and you only want to deal with integers instead. This is the case for us as we typically work with integers in our game, and for example, our timer will want to get rid of the decimal portion. Pico8 and Lua provide an instruction to do this called FLR, which stands for floor. Floor takes a single argument, which is the decimal number that will be truncated. So if you look at the example below, we truncated the decimal number, the one that was generated above, 35.4735, and the result of that instruction is simply 35. So one thing that's interesting is that we can now combine the floor instruction with the random instruction, and this way we can actually retrieve a random integer. For example here, if you wanted to get a random number between 0, 1, or 2, we would simply write number equals floor of random 3. This will bring 0 as part of the results, and sometimes that's not necessarily what you want. For example, let's say you're throwing a die or maybe 2 dice on the ground and you want to see the values. The numbers need to be contained between 1 and 6. So one thing that you can do is simply add 1 to the resulting integer. In the example below, floor of rand 6 will either return a number between 0, 1, 2, 3, 4, 5, and by adding 1 to the result, the resulting dice number will be either 1, 2, 3, 4, 5, or 6. Okay, so let's go ahead and see how we can use those two instructions to make our game a little bit more fun than what it currently is. So right now, the player can easily predict when they will be able to shoot, because it's always coming 3 seconds after the game starts. This is represented by this gray bar here called the cooldown. A more interesting approach would be to make this more unpredictable. We could figure out a random amount of time before which the player can actually start shooting. So let's say we wanted to have this gray bar be sometime anywhere between 3 and 6 seconds. Our code currently has a timer that represents 30 for 1 second. And rather than using a fixed cooldown time of 90, which is 3 seconds, we're going to get a random number between 90 and 180, which is pretty much a period of time that will last anywhere between 3 seconds and 6 seconds. So let's go ahead and hop into our code, and we're going to add this in. All right, so back into our code, let's see where the instruction to be able to allow shooting is inside our code. So right now, if you look at the update instruction, we currently increase timer by 1 in the update instruction, meaning that this is going to increase by 30 every second. This here will happen after 3 seconds, and we're changing the text from ready to shoot. And so this is the static instruction that we are going to want to change because we want to allow the player to start shooting after an arbitrary amount of time. We're going to need a new variable to store this random number that will be anywhere between 90 and 180. So let's go back to our init instruction, and we're going to create a new variable called shot timer. And we're going to start it with 3 seconds, a minimum of 3 seconds, and then we will do the floor of the random number of 90, meaning that we will have a random number between 1 and 90. This means that the shot timer will be anywhere between 3 seconds and 6 seconds. And we're going to replace the previous instances where we had the static number 90 by this new variable shot timer. So going back into our update method here, we're going to replace this with shot timer. We also want to replace this one here, which allows the player to shoot after the shot timer has passed. Now, the CPU should be able to shoot 1 second after that shot timer has concluded. So it's important to also change this variable. And we're going to add 1 second to whatever time was being generated. So now we have an arbitrary time, which is between 3 seconds and 6 seconds, and we will still have 1 second to shoot before we get shot by the CPU. Let's go ahead and save and try our game. So as you can see, it's now a lot more difficult to predict when the timing will be. Let me go ahead and try it again and see if I can have a little bit better reflexes. If you play the game multiple times, you will realize that the timing is going to be different at every single execution of the game. And we can play around with those variables a little bit to maybe have less time or more time. The more unpredictable it is, the more fun it can be. The second change that we can do to make this game a little bit better is to actually start adding levels with increasing difficulty. The difficulty of the game can be increased by having the CPU shoot faster over time, where other time would be reducing the length of time through which the player can be shooting, this green area. The first level could be whatever we currently have now, which is giving the player 1 second to shoot, whereas the final level could be giving the player 2/10 of a second to shoot. This is a great opportunity for us to use one of the variable types that we introduced much earlier in one of the previous videos, which is the table type. So let's think about how this is going to play out in our game. This is a very simple schema of what we currently have today. The clouds in the sky, the cactuses on the ground, and then the player against the CPU. Since we're going to have a couple of additional levels, it might be useful to actually indicate to the player which level the player is currently on. So what we'll do is we'll just print the level at the top left in yellow and indicate which level the player is on. Once the player has shot the CPU, we'll probably just wait 1 second, and then we'll have to display some sort of transition to the next level. So what we're going to be doing is simply having some sort of text box in the middle where we indicate to the player that they've beaten the current opponent and their older brother, and we'll come up with a couple of funny names there, is coming to avenge the younger brother, and then will indicate to the player that they have to press X to start the duel. This will allow the player to kind of have a pause between the various levels and understand that they're going against a bigger opponent. And we'll be doing this for roughly 5 levels. So let's go ahead and add that into our code. Okay, so back into our code, there's actually a couple of things that I want to do before we add levels. First of all, I just want to make sure that we only keep here the elements which are important for the game. We don't need to move the cloud anymore. So let's go ahead and move and delete this code here. And wherever we're moving the cloud here, so right now we are bringing it back to the left, we can just delete this code altogether. We don't necessarily need to draw it anymore either. Let's go ahead and delete this. All right, so now let's go ahead and save. And okay, so what do we want to do? We want to start by defining some levels. So we're going to have 5 levels, which means we're going to create a table containing 5 elements, and we're going to have as many of those variables as needed. The first table we're going to need is the names for the opponents. So maybe we can do CPU names. And here we'll go ahead and create a table with the various names that we have. And let's go with let's see, Tiny, Mikey, let's do Little Joe. We'll have some sort of mid-size Will. Let's have a Big Earl and maybe a Huge Sam. All right, so the names should indicate that the CPUs are better over time. The next thing that we want to do is to have an amount of time that gets reduced for the player to shoot as the opponents get harder. So right now, if you look at our code, we have a fixed amount of time, which is 30 cycles. This is 1 second. And this is going to change as the levels get harder. So what we want to do is create a new variable. Again, at the top here, CPU, let's call it reflexes. And we'll just have a table with better reflexes, which means a decreased amount of time after which they start shooting. We'll just decrease it by 6 every time. This means that 6 here represents 200 milliseconds. It's a fifth of 1 second. We'll see if that may be too hard. Okay, and then the next variable that we need to know is we need to keep track of which level the player currently is on. So let's go ahead and indicate this with a variable called current level, and we'll start that at 1. We'll be using this variable constantly to do a lookup in our tables. We will be able to know which opponent we're currently against by looking at CPU names and then using this variable with brackets. So currently we'll have bracket 1, Tiny Mikey, but as we increase the levels, we'll then be doing a lookup in both of those tables. So the first thing that we want to do is to display the current level in the top left portion of the screen. So let's go ahead and do that and go all the way to the draw function. And we want to do this every single time. So let's go ahead and print level. And this is something that we learned in a previous lesson, but I want to do this on purpose, do this error on purpose. We're going to do a plus and then the current level. And let's go ahead and print it towards the very top left, maybe 5 from the left and 5 from the top. We'll print it in yellow, which is color 10. And this shouldn't work because current level is a number and we're adding a number to a string. Let's go ahead and save, hit run. Now we're seeing an error, which is that we can't do an arithmetic between a string and a number. So if you remember, one of the lessons we learned a very handy instruction from Lua and Pico 8, which is the toString instruction. So we're going to go back here and we're going to transform our integer or number into a string by using this instruction here. Go ahead and save and run our game. Oh, we can't add two strings together. To concatenate strings, we have to use a double period. All right, so we have our level 1 top left. It's a little bit too much into the game, so let's go ahead and bring it closer. We'll just do a 2 and 2. Let's see how that looks. Okay, that looks much better. All right, so we need to be able to shoot the CPU and go to the next stage. So first of all, we need to swap the static amount of time by which the CPU is playing with the one in the table. So let's go into our update method here, and this indicates the amount of time after which the CPU is waiting in order to shoot. So what we want to do here is replace this 30 with the CPU reflex. It's reflex or reflexes? CPU reflexes. Go. Use the brackets, and then here we're going to enter the current level. So that when we start the game, we'll be looking at how much time do we need to wait before the CPU shoots. We'll be looking at the value for the current level. It will start at 1, which means we'll be looking at the first entry in the table called CPU reflexes. Currently, CPU reflexes has a bunch of entries, but the first one is 30, meaning 1 second. As we increase in levels, we'll be doing lookups of additional variables here, and so the CPU will be shooting a lot faster. Let's make sure that this works properly, and we should have the CPU shoot after 1 second. I'll go ahead and save and run our game. And the CPU shoots after exactly 1 second. Okay, so now we want to be able to have this text box in the middle to indicate that the player has won and is about to go against the older brother. Let's go back to our code, and where we are shooting, there we go. This is the winning condition. So let's go ahead and start by having this text box in the middle of the screen. Let's go ahead and write our commands. So let's see, ubeat. And here we want to concatenate this with the name. So CPU underscore names of the current level. So we'll be fetching the current opponent. And let's put maybe 40 pixels from the left and 50 pixels from the top. Let's see what that looks like. Let's also use the color yellow. Print his older brother. And this time we'll want to get the next entry inside the table, which means that we can do current level plus 1. We'll display this at the same horizontal space, but we'll just place it a little bit further down, so maybe 60 and 10. And finally, we want to allow the player to start the next round. So we'll indicate press X to start the duel, and we will place this just a little bit further down. So let's see, same distance horizontally, but this is 60, let's put 80. All right, let's see what this looks like. So let's go ahead and win this duel. Ready, and shoot. All right, and we want to get things a lot closer together. So let's go ahead and change this. Let's do 15, and rather than doing 50, we'll do 56. Actually, let's do 58. And here, let's do 66. All right, let's win this one and see where the text is being displayed. All right, so it's a little bit better. It's still way too far off from the top. Let's go ahead and bring this up a lot more. Maybe we'll do 20, 28, 36. All right, so this is much better. Actually, we'll bring it up a little bit more, and then we'll need to have some sort of darker background behind this text. Let's go ahead and get back here. We'll bring it back up a little bit more. So rather than being 20, we'll do 16. So we'll reduce everything by 4, 24, and 32. And we are going to also have a rectangle to fill just behind whatever we're printing so that we can see the text a little bit better. For that, there's actually an instruction I don't think we have learned about called rect fill. Rect fill creates a rectangle and fills it with a specific color. For that, the arguments are the top left position of the point and the bottom right position of the rectangle, and then a color to fill it up. It's a fairly easy instruction to use, so let's go ahead and try it out. So currently the text is starting at 15, 16. We're just going to start the box a little bit before that. So let's do 13 and 14, and we will go down all the way to let's try 140, and let's pick a dark color, maybe this gray here, color 5. Let's see how this looks. So we'll be printing the rectangle, we'll be filling it out, and then we'll be printing the strings. Let's win this game. All right. It's not too bad. The rectangle is a little bit too big and just not large enough. So let's go ahead and fix this. Let's bring this to 120 and a little bit too tall. So we'll just bring this down to 38. Let's see how this looks. Okay. So this looks much better now, and we have indicated to the player that they need to press X to start the next level. If you press X, currently nothing is happening. It's because we're not handling the state right now. So let's go ahead and press Escape, and we will go into our update instruction, find where the player has won the game. All right, so here we have an update function that specifies whether has shot is true or not. So what we can indicate here is if has shot, meaning that the player has won, and the button X is being pressed, then this is where we would go to the next level. So how do we go to the next level? Well, the first thing is we need to increase the current level by 1. And second, we need to reset the fact that the player has shot. So has shot will be equal to false. And we also need to reset the timer and go back to 0. Finally, we will want to create a new random shot timer, similarly to what we had done initially, so that it can be a different amount of time for every CPU to beat. So if we go back to what we had created here, we're just going to repeat this instruction for now. So I'm just going to copy it and paste it here. So what will happen at this point? Once we have done all of this, we will then go back to the very top here. Scene will be inside the game, we'll be increasing the timer, we'll be having the ready text probably needs to also say ready. That's another thing that we initiated that we need to do. So let's go ahead and copy this and bring it down here. All right, so we'll be resetting the ready text. We'll be resetting the timer. We'll be creating a new time after which the CPU will start shooting. We'll have a new opponent, increase the level, and that should be it. So let's go ahead and start and run our game. Let's see how far I can go here. So ready, shoot. Oh, it didn't go and show the screen. And the reason for that is because we're using the same button to shoot and to dismiss the screen. So maybe let's change this. We're going to ask the player to use the circle button to move to the next level. All right, let's try this again. So here, I shot the player. He beat Tiny Mikey, his older brother Little Joe. Oh, I guess we're missing some part of the text here. press circle to start the duel. So let's go ahead and press circle. And now I'm playing against the level 2 opponent. Going to try to beat him. And now we're moving on to mid-wheel. Press circle to start the duel. And let's see if my reflexes are fast enough. Shoot. Okay, Big Earl is next. Level 4. All right, and now Huge Sam is next. This is 20th of a second. Ready, and I just wasn't fast enough. All right, so this is working pretty well. There are a couple of things that we need to fix. First of all, the string is a little bit too long, so maybe we can just reduce this by saying he's old bro. See how this looks. Go ahead and shoot the first guy. Ready, shoot. He's old bro, little mad. Oh, I forgot to type the text all together. So let's go back here. This is after the name is being printed. He's mad. All right. Otherwise, it just doesn't make any sense. All right. He's old bro, little Joe is mad. Press circle to start the duel. Go to the duel. Level 2. Ready. Shoot. Okay. All right. The text is still not good enough, and we're going to fix this right away. Let's go ahead and bring the rectangle a little bit closer. We'll bring it maybe 5 pixels closer to the left, and we'll bring the text 5 pixels closer to the left. It's going to be 10, 10, and 10. Let's see how this looks. The box is probably going to be too far to the left. It's actually not too bad. Maybe Tiny Joe, this old little Joe is mad. Press circle to start the level. All right, so let's see if we can beat the game at this point. Beat little Joe. Ready. Shoot. Okay. Big Earl. All right, and Huge Sam. Let's see if we can beat Huge Sam. Nope, still not. Still too slow. Well, probably you might be able to beat him. One thing that I wanted to show you, and we'll probably get to this at some point, but what happens when we actually do beat whatever that guy's name is? Big Joe? What is it? Little Joe? Huge Sam. So what happens when we beat Huge Sam? Well, when we beat Huge Sam, we're going to enter this if condition here. However, the problem is we're going to increase the current level by 1. We're going to reset everything, and we're going to go back into our loop. What is going to happen is we are going to try to print, well, first of all, we're going to try to access the 6th element of a table. We'll try to find the name of the older brother of Huge Sam, which doesn't exist here. So we're gonna have an error thrown by the program, which is that we can't find the next player here. Same thing for the CPU reflex. So inside our update method, one thing that we need to do, and this is something that you're going to have to be careful with whenever you increase the index of a table, you need to make sure that you are not fetching outside of the bounds of the table. So before we actually make all of those increases, what we're going to do is to have another if condition, and we're going to ensure that the current level is not bigger than the size of the levels. So for that, we're going to look at the size of maybe the CPU names. And if the current level is smaller than the size of CPU names, this is 5 by the way, as it stands right now, then we'll be able to increase it. So let's go ahead and close this condition. And here, inside this else here, this is going to be the actual win condition of the game. This is when you've beat Big Sam, and this is where we are going to have the next challenge. The interesting part here is going to make it fairly enticing for the player to actually complete the game. We'll have some sort of final screen and a new scene where we'll be transitioning towards. Okay, so we're just about done with this game. The one final thing I'd love to do and have you try to do is to build a final state, a new scene to indicate that the player has actually won the game. He's defeated all the brothers, and we want to have some sort of special artifact for the player to enjoy, and some sort of final state that indicates that there's nothing after that state. So create a new scene in our game organization and transition to that final state at the right moment, with perhaps maybe a unique sprite or an animation or something that moves with some text that indicates that the player has completed the game. Go ahead and try to complete this challenge now, and after this we'll just have one final lesson to add sound effects and music to the game, as it's never complete without some sort of audio artifact. Go ahead and pause the video now and try to complete this challenge. Okay, so what we want to do is to create this final state, which is when the player has shot the last brother, we want to change the scene and transition to the end game. So for that, we need to find where in the code the player actually beats the game completely. Inside the update, this is every time the player is able to shoot an opponent. And so this is where we want to check if this was the last opponent. So for that, we can check the value of current level. This will go between 1 and 5. And so if the current level is equal to the length of the names, so for example, we have 5 people in the array now, and within this table, once we reach the 5th person, the size will be equal to the current level. So this is where we want to transition of the current scene to something other than game, and maybe we can call it end. All right, so now we don't have anything to draw when we are inside this scene. So let's go into our draw state. This is where we are in the title screen. And right now, let's go ahead and let's use, similar to what we did here with this else if, let's use another else if here, since we're gonna have 3 states for the scene: title, game, and ending. So else if scene equal game, and then we're going to keep that as it is and just go all the way here, and let's create a final else. This is when the game is completed. So here we already have cleared the screen. We're just going to print just some congratulations at the end of the game. Print congratulations. Let's put that somewhere towards the middle of the screen, maybe at 30 in yellow. Print you have won. Let's also print that here, and we could probably center it. Maybe that's what we'll end up doing. And then we want to display some sort of winning sprite. Let's go into our sprite sheet here. Let's pick a new sprite here, and let's draw maybe some sort of cup. Let's see. Control Z. Let's see what if we had something that came maybe like this. Let's bring it down here. All right, this should start looking like a cup. Maybe we can add a bit of, actually, let's just paint it in yellow and add some shades here. Is it starting to look like a cup? I don't know. I am not the greatest artist. Maybe we can bring this here and put the black here instead. Okay, this looks absolutely amazing. Let's do this here. So this is sprite number 35. Let's put it somewhere on our screen. Sprite 35, and let's put it halfway in the middle, and maybe, so this needs to be 38 pixels on the top. Let's do maybe 50 pixels on the top. All right, let's go ahead and run our game. Oops. And close the function at line 24. Oh, it looks like I forgot an and somewhere. Okay. All right, so let's try to beat the game here. I'm just going to cheat a little bit, cheat my way by, pressing repeatedly on the shooting trigger. But that's because my reflexes are slow. We probably want to fix that at some point in time. Maybe you can do this in an extra challenge. Okay, so Huge Sam is mad. Let's go ahead and try to beat Huge Sam. All right, there we go. There we have it. This is our final screen. And this is going to be it for this lesson. We now have a full game. It's a little bit more fun. It's a little bit more enticing. I do think it may be worth it to actually prevent the player from trying to shoot before the ready and shoot indicator is done. Maybe this is something you can do on your end. In the next lesson, we'll be learning how to add sound effects and music, and this will be it for this first game. It's a very simple game. We are only using 2 or 3 very basic concepts of programming, variables, conditionals, and our code, to be honest, is not the greatest because we don't have a whole lot of things to work with. But in our next game, I'm really hoping that we do something that is a lot easier to read and a lot more enticing to play. See you in the next one.